Alright, hello AP Physics students and welcome to this tutorial on how to graph using Microsoft Excel. We're going to be using Excel quite a bit in this class, and really the main thing that we use Excel for is going to be to graph data sets that we collect and then actually analyze that data and derive equations from the data that we collect. So let's just jump right in and create our first graph. So the easiest way to do this, and this is probably a review for some of you, but we're going to highlight our data set here, and we're going to go to Insert, and we're just going to go to a typical normal scatter plot. Okay. Now to create a good graph, we want to put our graph title, which is going to be distance versus time. Remember that we always title our graphs y values versus x values. Okay, so we have y versus x. And then we're also going to add in axis titles. So our horizontal axis is going to be our time, and we'll add our units in there. And then we'll put in our vertical axis, or our y axis. And that's going to be distance, and the units for that are meters. Okay, so we're not quite done with this. We still have to do arguably the most important step with these graphs, and that is we want to see how accurate this data is to an ideal model of that data. And how we do that is we're going to add a trend line. So we're just going to pick one point, and we're going to right click, and we're going to hit Add Trend Line. And a bunch of different options are going to pop up here. Now, if you take a look at this data, you can just give it the eye test here. And this looks very linear. Okay, and we're actually going to check to be sure that it is linear and that we're on the right path here. So we're going to scroll down, and we're going to hit Display Equation. And then we're also going to hit Display R Squared Value. Now, this R Squared value is really important. The R squared value is the square of our correlation coefficient. So what that's telling us, the correlation coefficient is telling us how close our data is to the ideal model. The ideal model here being our trend line. Now, how we read this correlation coefficient, or the square of this correlation coefficient, the closer we are to 1, the better our data is. So we're at 0.992. That is very, very close to 1. That is showing us that, hey, the data that we collected is really good. It aligns closely with this ideal model. So we're cooking, okay? So the big things here are just basic making graphs. Be sure that you're putting your titles, and then also add in your trend line with your equation. Okay, this equation, it's in y is equal mx plus b form. So obviously this 2.06 is your slope. This right here is your y-intercept, and it's probably supposed to be around 0. Not quite ideal data, I guess, there. But this R squared value is showing us that our data that's collected is very close to the ideal model, and that ideal model again is our trend line. So now moving on, let's say that we took data from two different, in this case, two different cars, and we wanted to compare the data between these two cars. Now, typically, if we're graphing distance versus time, we're taking a look at the speeds of those cars. Okay, so here we'd be comparing the speeds of these two cars. So to do this, yeah, we could graph these on two separate graphs, but it's going to be difficult for us to actually compare that data to one another. So what we're going to do is we're just going to pick one of these data sets to begin with. So highlight that, and we're going to do the same procedure that we did on the previous sheet. So we're going to go up here to Scatter. Now again, let's put our titles in here, distance versus time. Let's just add in our axis titles here quick. So this is going to be time down here. We have seconds, lowercase s, and then our vertical, which again is going to be distance. All right. So there we go. Now, this is our data for car 1. We know that. Now, we want to get car 2 on here. So a good way to do that is, again, to right-click one of our data points, and we are going to go to Select Data. And we're going to go here to Add. And now we just have to plug in the values that we want here. So our X values are going to be car 2's time data. And then our Y values, we're just going to highlight car 2's distance data. Okay. And then we click OK. So now we can see two different data sets on this graph. However, which is which here? So we're going to go up here to Add Chart Element, and we're going to throw in a legend over here. Now this is telling us Series 1 and Series 2. We can actually designate Series 1 and Series 2 as car 1 and car 2. So what we're going to do then is right-click one of those data points. We're going to go to Select Data. And right now we have Series 1 highlighted, so we're going to edit that. And we're just going to type in car 1. And we're going to click OK. And then we're going to highlight car 2 here, hit Edit, and we're going to type in car 2. So we click OK, and now we can see here that our blue data set here is car 1. Our orange data set here is car 2. Now, we can again take this a step further to really take a look at this data, and we can add trend lines. We can add trend lines to both of these data sets. Okay, and then I'm going to add a trend line to this one too. So typically, if we're looking at two cars and we're actually going to be graphing eventually data very similar to this to take a look at the speed between two cars, but we're really going to be focused on not only the shapes of the graphs, okay, which slope is steeper, but we're actually going to be looking at the numerical value of the slopes. All right, so finally in this tutorial, I have 3 different data sets here. Okay, and I'm going to create an initial graph for each of these data sets, and we're going to take a look at the shape that these data sets make. Notice that in these first 2 sheets, our data was very linear. Okay, our data was very linear. So we didn't have to really do much. We threw our trend line in and it was good to go. Same thing here. Very linear. We didn't have to do anything. And in fact, our R-squared value for both of these was 1. So we knew that we were right on track with our data in comparison to that ideal model. So we're just going to jump right in and take a look at these graphs. So again, highlight your data set, do a scatter plot, and now you see, wow, we're not linear at all anymore. Our data here is a little wonky. So just for the heck of it, we could put in a trend line and we can take a look here. And it's pretty clear that it's not linear, but let's take a look anyway and use the power of Excel. And we can see that our R-squared value, like while yes it is high, it's not really close to 1. So we know that this model that we have right here is not a great one. So we could very well sit here and play around with these different trendline options. We could try exponential, we could try logarithmic, we could try polynomial, we could try power, we could try moving average. But in physics, we want to make things as simple as possible. And I know maybe it doesn't seem like that all the time, but we want to make things very simple. Simple in the way that this data was simple. Okay, this model is simple. It's a line. Again, same here. This model is simple. It is a straight line. We don't want to throw in stuff that has curves. That makes our life very complicated. I mean, look at this equation that we have here. We have a natural log in here. I don't want to deal with that, and I hope you don't either. So we need to some way try and make this data linear. Okay, we need to linearize this data somehow. And I'm going to give you this fancy little graph or this table here. But if you take a look here, it breaks graphs down by graph shape, the relationship that we see there, the modification that we need to linearize the graph or linearize the data, and then the mathematical model that gets attached to it. Okay. Now, if you take a look at these graph shapes, you're going to see a bunch of different shapes, but at the very bottom, we see a shape that really closely matches the shape that we have in this graph. Okay. Very close to what we have in this graph. And if you remember back to your math class, that's showing us an inverse proportion. So what that's saying is that as x is increasing, y is decreasing, except that y is not decreasing proportionally or directly proportionally to x. So we have to do something to x to get it linearized. So if we take a look at how we linearize that shape, we need to graph y versus 1 over x. So we need to be graphing y versus 1 over x. So how do we do that? What we have to do is we have to manually change these x values. Okay, we actually have to manually put in that inverse of x. So what I'm going to do in this column here, I'm going to type in 1 over x. And then what I'm going to do is I'm going to type in an equation. So I'm going to hit equals 1 divided by, and I'm going to click this cell right here. Press enter, and then all I'm going to do is drag this down. Okay, so we have this new data column, which is our inverse of x. So now what we're going to do is we're actually going to just change this graph entirely. We're going to right click on one of these data points. We're going to select our data, and we're going to edit this series. So instead of having our x values in this x value spot, we're now going to highlight our inverse of x. And then we're going to click OK, and then OK. And now, if we take a look at this graph, we have a new, beautifully linear model, and our data is also, just giving it the eye test, is very linear as well. And we can prove that it is very linear by, again, looking at our r squared value. Again, it's pretty close to 1, so that's telling us that this new data that we have here aligns very closely with this ideal model that we've created. So I am going to be doing one more of these for you, and then I'm going to have you on your own try this last one to get a little bit more practice with doing this without my guidance. So I'm going to delete this graph, and we're going to start working on this second data set right here. So again, standard procedure. We are going to insert that scatter plot, and now if we take a look at this, we can add in our trend line just for the heck of it here. Take a look, we'll keep it linear, because remember, we want to try and linearize everything. And now if you take a look at this, I mean, our r square value is pretty high. It's close to 1, but if you look at this data, it looks very parabolic to me. It doesn't look very linear. Okay, we kind of have that U shape going on here. So we're going to take a look at this chart that we have and take a look at our graph shapes over here. And we see that one of our graph shapes could be a parabolic relation. So knowing that we have that, again, we want to linearize this data to make our lives as simple as possible. So we're making as simple of a model as possible. And when I say model, I'm really talking about making the simplest equation possible. All right, so what is this telling us to do to linearize a parabolic? It's saying that we need to graph y versus x squared. So again, we're going to go back here and we're going to automatically, or not automatically, we're going to manually change those X values. So I'm going to hit equals, write in 5, and let's see here. I want to bring this up to the second power. All right, we got that, and now we're going to drag it all the way down. Perfect. So now what we need to do is, again, click this data, select the data, edit, and then we are going to just select that data. Uh-oh, it didn't like that. Oh, I got a whole bunch of stuff in there. We'll delete that. Try it again. Highlight all this data. Click OK. OK. And there we go. So now we have a very beautiful, linear, great model. We have great data. Our R-square value is actually 1, which is phenomenal. So life is good here. Okay. So I want you to try this last data set on your own. It's going to look differently than the first two did. But just be sure that you use this fun little chart here to give you some insight into what you have to do with your data. Okay? So good luck, and I hope that this tutorial helped you understand how to graph in maybe more advanced ways than you already knew in Excel. Take care.